Hi again, everyone. Dr. Tom McNamara here for our course in college algebra. We're continuing our work with polynomials, and we are going to talk about finding zeros of polynomial functions. Okay, so in some previous videos, we had listed out three key factors that we need to look for to understand how a polynomial is behaving. And I'll just highlight them right here so that we keep this in mind. First thing to look for is the end behavior of the polynomial, which we can determine by looking at the degree and the lead coefficient. The second important thing were what were the zeros of the polynomial function, which is equivalent to saying what are the factors, which is equivalent to saying what are the x-intercepts. So this is the aspect of polynomials that we're going to focus on in this video, finding those zeros, which, as we'll see, and as we have seen, is equivalent to finding factors, which means we know the x-intercepts of the graph. And then the third thing is, does the graph cross or touch the x-axis at those x-intercepts? So remember, those are the key things. In this video, we're focusing here, finding zeros. So the steps are make a list of possible zeros. We're going to make use of something called the Rational Root Theorem, but it's actually an extension of something you already know. So we're going to make a list of things that could be zeros, and then we test which of those actually are zeros. We'll typically make use of synthetic division to figure that out. So I want to do a little warm-up with you here. Okay, so this is a problem that we already know how to solve. Okay, finding zeros of this polynomial is equivalent to doing this problem, solving this equation. X squared plus 4x minus 12 equals 0. So when we're tasked with something like this, the first thing I try to do is factor the polynomial. And this is a quadratic, so shouldn't be too tough to factor it. I start by zoning in on this. I'm looking at the 12. I'm thinking I need two numbers that multiply together to give me negative 12. Okay, so the only, well, actually there's quite a list of numbers that do that, but the numbers I'm thinking about are 1, 2, 3, 4, 6, 12. Okay, those are all possibilities. Now, in this case, we're saying, okay, how do I narrow it down? Well, I need a pair of those that add up to 4. And it's not too hard, so I'll just finish the problem off here. I think the factoring goes x plus 6 times x minus 2, and we can always check our factoring by doing the multiplication. X squared minus 2x plus 6x is plus 4x, and then minus 12 for the constant term, so we've got the right factoring. And then once I know the factors, the zeros are x minus 6, or x equals minus 6, and x equals 2. Okay? So a little warm up there. So the key thing I want to emphasize is that if I'm trying to find zeros, I got to focus in right there. I'd start by looking at that constant term. Numbers that go into 12 evenly are going to inform what I should be thinking about. In other words, that's going to be on my list of possible zeros. Right? There's a little more to it than that, and I'll show you another example where we can see how to extend. But let's go and tackle a harder example where we actually have to use the synthetic division. Find the zeros of p of x equals x power 3 minus 6x power 2 plus 11x minus 6. start out by making my list of numbers that could be zeros of this function. Just like the warm-up example, I focus my attention right there on that 6. Anything that divides 6 evenly could be a 0. Not too many things. 1, 2, 3, and 6 could be zeros. I should account for positive as well as negative. Okay, so in other words, positive 2 divides into this evenly, but so does negative 2. Okay? Either sign will work. So those are the things that could be zeros of this polynomial. So how do I find out what actually is a 0 of this polynomial? Well, I'm going to test. I'm going to use synthetic division and test. So we could start out just with the first thing on the list. Let's start out with 1. Okay, so 1. Remember, whatever's here, we drop it down, we multiply. -5, we add. -5, we multiply. 6, oh, so close. Let me just make sure I did the arithmetic right. Drop it down, multiply, add. Oh, actually, I had the sign wrong there. Okay. Add, multiply, add. Okay, I'm multiplying by 1 every time because the 1 is right there. And, well, I kind of lucked out. Okay, the remainder is 0. The factor theorem that we discussed in a previous video tells me that if my remainder is 0, I have found a factor. Okay, so let's make a couple of notes here. So x equals 1 is a 0 of this polynomial. And that is equivalent to saying x minus 1 is a factor. And more than that, the synthetic division setup tells us what the other factor is. Remember, over here, these are the coefficients of the quotient. Okay, the coefficients of the quotient. So, my original polynomial p of x is equal to x minus 1 times x squared minus 5x plus 6. And now I can focus on factoring that. Okay, I don't need to test every single number on this list. Okay, that would be 8 things to test. I know this can only have 3 possible zeros. Okay, I've already found one of them. Now I just have to find the zeros of this other factor. So every time you get a hit with your synthetic division, you simplify the problem. Right, so not too difficult there. I think it's x minus 2, x minus 3. All right, that quadratic polynomial factors into x minus 2 times x minus 3. So a list of the zeros of this polynomial, x equals 1, 2, and 3. Okay, notice everything that turned out to be a 0 was on this list. Now, there's stuff on this list that did not turn out to be a 0, like plus and minus 6 were not zeros. Remember, this is a list of possible zeros of our polynomial. Okay? How do we find out which ones actually are zeros? We test with synthetic division. Once you find a successful result of your test, you get a 0 for your remainder over there, then you simplify the problem, break it down further. Okay, let's do another example. Okay. Find the zeros of this polynomial. P of x equals 2x cubed plus 3x squared minus 8x plus 3. Okay. I'm going to do a little review example here. Now, very similar, for our list of possible zeros, I'm going to have divisors of 3 as my starting point. Okay, divisors of 3, but this thing over here, this coefficient being different from 1 throws a little monkey wrench into the works. Let me show you why. If I were to do this, let's do 2x squared minus 5x minus 3 equals 0. Let's say I wanted to solve that equation. So I'm looking at the left-hand side, I want to factor it. Okay, so I know that these terms, if this thing does factor, one of them has to have a 2x, the other one has to have an x. That's the only way to get this. All right? And let me see, I think this guy does factor. I think it factors like that. Okay, remember we can always check by multiplying. 2x squared minus 6x, because we have 2x times minus 3, so minus 6x plus x for a minus 5x, and then minus 3 over there. So my zeros are x equals 3 from here, and then I have to think, what makes this factor equal to 0? -1 is not the right answer. Some folks get into the habit of, oh, you just look there and change the sign. It's a little more to it than that. You have to take the factor, set it equal to 0, and solve. Now, for a case like this, it's so simple we do it without thinking. If x minus 3 equals 0, that means x equals 3. We solve it by adding 3 to both sides. Okay? But here we got to think for a sec. 2x plus 1 equals 0. What does that mean? That actually means x equals -1/2. Okay? 2x plus 1 equals 0. Subtract 1 from both sides. 2x equals -1. Divide by 2 to get x by itself. X equals -1/2. Okay, so if this thing is not 1, if the lead coefficient is different from 1, we have to account for the possibility that we could have fractions for zeros. Okay, so we're making fractions. You can have whole numbers too, but you got to allow for the possibility of fractions. Okay, so for my numerator, I can have any divisor of 3. Anything that divides 3. Where is that coming from? It's coming from right there. For my denominator, I can have any divisor of 2. From right here. So fortunately for us, there are not too many divisors of 3. So the numerator for this fraction has to be a 1 or a 3. The denominator could be a 1 or it could be a 2. And I got to cover all my bases here. So I could have a 1 or a 3 on top with a 1 in the bottom. I could have a 1 or a 3 on top with a 2 on the bottom. Remember, we got to account for plus and minus on all of those. Okay. So my list, if I simplify it even further, plus and minus 1, plus and minus 3, plus and minus 1/2, plus and minus 3/2. Okay? Now I'm going to cheat a sec. I actually worked out this problem before, so I'm going to look at what I did, and come on, where are we? Okay, great. I'm going to let that inform my test. Okay, so you can start testing anything you want on this list. I'm going to start by testing 1/2. Okay, so 2, 3, -8, 3. It'll also give us a chance to get some practice with a fraction out there in the synthetic division setup. Okay, so we're testing to see whether x equals 1/2 is a 0. Okay, drop it down. 2, multiply. 1/2 times 2 is 1. Add a 4, multiply a 2. -8 plus 2 is -6. Multiply -3. We get a 0. Wonderful. Okay? So x equals 1/2 is a 0. So that means x minus 1/2 is a factor. What's the other factor? Well, 2x power 2 plus 4x minus 6. That's the other factor. Notice everything there has a 2. So I'm going to pull out a factor of 2. That's coming way out here. So that is x squared plus 2x minus 3. And lo and behold, this thing does factor. All right, write it up here. We've got that 2 hanging out there. X squared plus 2x minus 3. X plus 3 times x minus 1 does the job. Okay, so I've got my polynomial factored. Great. It did say find the zeros, but of course we know if we have the factors, then we have the zeros. X equals 1/2, x equals -3, and x equals 1. Okay, so remember, degree 3, we are looking at 3 zeros if we count with multiplicity. Okay, so 2 examples of finding the zeros of a polynomial function. Start out by making your list. How do you make your list? Look at the constant term and look at the lead coefficient. Your list should contain anything that divides the constant term on the top, anything that divides the lead coefficient on the bottom. So your list could include fractions if this is different than 1, like we're seeing right here. Okay? So make sure you work through the exercises and get practice doing this. It's actually pretty easy once you work some examples. So make your list by doing this. Now if this is a 1, don't even worry about that. If this is a 1, you'll get whole numbers on your list. That's the simplest case. If this is different than 1, then you have to account for the possibility that you're going to get some fractions. Okay? And as we see here, 1/2, the fraction 1/2 actually did work as a 0. Okay?